Hello, everybody. I'm very happy to be here. My name is Christian Hardenberg. I'm Chief Technology Officer at Delivery Hero. I was here 2 years ago. Happy to be back. Last time I also talked about velocity, but a bit more around how to build fast code, fast website, fast servers. Today I focus a bit more on the organizational side. I'm a coder myself. I started at the age of 9, I think, on an Apple IIc. Ever since I was fascinated by technology, worked at Rocket Internet as CTO, but also at some other companies you can see here. And I think we are just in very, very exciting times because the more every day I see more and more of the world is run by computers, and we are the guys, we coders who run those computers. You can really see that well at Delivery Hero. Delivery Hero is a company that does online food delivery around the world. And in the last half year, we made 132 orders, 132 million orders. Imagine this pile of food. Imagine 132 million bags. It's actually not a pile, it's a mountain. And this is only possible because computers run that. It's not us. Actually, on a Sunday, when all the people are at home, it still works. It works best on Sunday. We make most orders there, and that's what I find so fascinating. And it really works. A customer takes this phone, does a few taps, goes to the restaurant, comes back, is getting delivered, and all that takes around 30 minutes. Most of this is done by computers. So this computer is the first one. Then we go to the server where we try to match those hungry customers on the one side with all the food options on the other side. We have actually millions of different dishes on the side. And try to use all the data we have, and increasingly so, to personalize this experience and make sure you get the food you really like. And then a lot of other computers, not just ours, but we use Amazon and Google Maps and New Relic and Splunk and Cloudflare, and all these computers work in the background and send data forth and back to make it as easy and efficient with Optimizely there, for example, to make the customer, what I find so expensive, in the end, you just need to do those 4 taps. You tap on a restaurant here, dump door, let's say, tap on a dish, and you tap on place order, and you're done. That's all the customer has to do. And then thousands of servers start working on it, and it goes to this nice device, which is also a computer. It's a bit of the old version, has only 10 buttons and prints this is how we started. Now it looks a bit more like that. We give these tablets to the restaurants where they then receive the order and get also help to route it and manage their drivers. And from there, it goes to the kitchen. So some people we still need to get the food cooked. That's not us. That's our real heroes, the restaurants. And from there to the drivers. We have a lot of drivers from Foodora and others, more than 10,000 around the world, which we run, plus the restaurant drivers. And they also have a computer. They have an app in the pocket, which always tells them where to go, how to route. And as we have so many drivers, actually, that at the beginning we did manually tell them, you do this, you do that, but this didn't scale. So now we are proud that 99% of all our orders are completely automated dispatched. So no one has to touch them before they go to the driver and find the best route to the customer. We are working on also replacing, or let's say, using computers for the delivery side. This is a test we have been running here in Hamburg with our Starship technologies. And we can actually now deliver food also by robots. And then even that is done by a computer. So the customer does 4 taps, and 20 minutes later, it rings at the door, and you have your food in the hand. I think it's still magic how that works. And it only works because tech. And that's what we do. And tech is really in every single step of this process and in many more. And we put it here all on one slide, and it's probably even more than that. And in the way we do marketing, in the way we select our restaurants and so on. And well, that is not enough because we have to do it at scale. And let me just quickly talk about the scale we are running at Delivery Hero. So I already it all started in 2008. This is how it worked. And then Delivery Hero is a company that bought a lot of other companies over time. This is how we grew. So that's also why it's maybe not so known here in Germany, because Delivery Hero is not a brand, but you might know Pizza.de, Lieferheld, Foodora, which are part of Delivery Hero. And we grew, and now are a quite global network across 42 countries, all the way from Australia to Canada, from Bogota to Kuwait, from India to Korea. And across all these countries, we do the same. We deliver food. We also, as we grew in brands. We have 30 different brands on the platform. Most of them you probably don't know, but Yemek Sepeti, the biggest one in Turkey, or Hunger Station, you probably never heard, but it's the biggest one in a place called Saudi Arabia. But Foodora, you hopefully know. That's here in Hamburg. We're doing fine, 132 million orders, almost 2 billion in GMV, and we plan to go across 500 million in revenue this year with the food delivery. It's all growing nicely, and it will continue to grow, so we as the tech guys need to find a way to scale our systems. That's our headquarters in Berlin. We are around 600 in engineering now, so quite big already. And also the market is nice. And then I go to the tech side. The red piece there in the corner is really what we are right now, the 2.6 billion in GMV. But if you take the whole takeaway market, it's the green part. If you then continue to take the whole restaurant market, it's 500 billion. And then you could also look at the whole food market, including groceries. So then you're in the trillions of euro. So it looks good, doesn't it? We are actually the biggest in terms of order in the world. It's a huge market. It's all running completely automated. We could lay back and relax and just take the money, but it doesn't work because we need to actually, the problem is we are not alone. If there's an attractive market, there are other people who also want to take a share of it. And some of those are like guys like Uber, Amazon, are a bit, let's say, also powerful. So today it's really about how do we win this race. And if you compare it a bit with the Formula One race, I think we are all like Formula One teams. We have a lot of money and people and know-how and ambition. But in the end, we run on similar hardware. So we all run somehow on the cloud, on the Amazon systems. We all use open source technologies. We all use probably similar types of databases and so on. So it's not really the hardware or the car that wins the race. It's much more than it's the strategy, the team, and the way we run this race. But first of all, what's the race about? We say probably the one who creates this amazing experience is winning. It's not about who has the most marketing power. But it's, in the end, people go back if they had a great food, great ordering experience, great service. So we need to run really fast to be better than all the others to win this race for the customer. The problem is the others also know that, and they also work on that right now. So how can we win the race for the best customer experience? And that's what I call velocity. Velocity is it's just about how, as we are almost complete a tech product, how can we innovate and change this product as fast as we can to get even better every day? How can we test and change and learn from the data and how to get even better? So velocity is not so hard without scale. Velocity without scale looks a bit like this. I showed it last time. It's just this amazingly efficient team of 4 guys who can do everything. The problem is this team doesn't work with 1,000 people. It wouldn't. This is not how they operate. And this is also a bit how a startup would operate. If you put 5 smart, hardworking guys in a room, give them the right goals and money, and they work day and night, probably they'll be extremely fast in getting amazing things done. But if you try to do this the same with 500, you will fail. The reason is very simple. It's this picture here. The reason is that the 4 people we just saw, they have 6 communication lines. While if you scale that to only 14 people, you have that in the corner, it's already 91 lines of communication. That still could be one team. Obviously, as you see, the whole figure is exponential. So the more people you add, the worse it gets. And you just get stuck in communication and dependencies. It's impossible that everyone knows what the other one is doing, and you get slower and slower, and at some point feel like you're not moving at all. Like everything you do takes a year suddenly, what as a startup could be done in a couple of days. So I've been thinking a lot about what can we do against that? How can we win the race with a large team? Because a small team can't win it. It's like in Formula One, you can also not compete if you only have a small car. So let's think a bit about what drives velocity, what makes us fast at scale. And it's a lot of things. It's what people we hire, what culture we have, how we organize, how it's our architecture, how we make sure we actually work on the right things. If we're fast, it's not good enough. If you drive in the wrong direction, it's useless. How we use goals to get there, how we use data, agile communication. And I can't talk about all this today, unfortunately. I would like to. I have a lot of, we can maybe, if you have questions about other things, I'm happy to answer in the end. But I would focus today a bit more on these three things here, which is how we build an organization that is a tech organization, obviously, that is a high velocity organization. What's the architecture and tech we need, and how do we operate that? So we start with the organization. So organizations for velocity at scale. We just saw this amazingly efficient team, the startup team. And obviously what we want to try is replicate that at scale. So I think it's very straightforward to just take such a team and do many of them. But many large companies don't do that. They specialize. So then they break up the team, an ops team and a DBA team and a product team and a quality team and so on. And then you lose this efficiency. So what we do, what probably many do, and what also I didn't invent, but Spotify talked a lot about this, is really building these squads. You can also call them cross-functional teams, where you put all the things in one room that you need to get the job done. They have their own product and design people, their own QA, their own mobile developers, their own infrastructure, their own operations. So the end is that as in a startup, you have everything there to reach your goals. You're not depending on others, and with less dependencies, less communication lines and so on, you can be faster. The only downside is you don't want to build huge teams. We want to have 6, 7, 8 guys in a team maximum, or girls. And so the only way to get there is that you need to wear multiple hats. And that's what DevOps is all about. Suddenly a developer needs to do operations, or a developer needs to do test engineering, or be a DBA, or be full stack. So it's not just the back end, but you also need to know about the front end side, even the mobile side. And that's what we increasingly ask from the developers, to be completely end-to-end able to run all these technologies, from low-level system stuff to all the way to the front end. It's asked a lot. It's a lot of technologies. But I think it's also more interesting, and it's more fun, and it's very nice challenge to be able to jump from system side to front end side and back. But also in other areas, I've seen really good QA people doing product doing QA, design done by even developers. So all that works. And that is really the requirement to make the system work. The other requirement is it all fails if you don't get this culture into the team to say you are responsible end to end. We give you everything you need. You're autonomous. These are your goals, your OKRs. But if they then don't take this responsibility, it doesn't work. So they, of course, need to be on call if something fails. They need to make sure there are other dependencies they fight to get them solved. That's what I typically tell them. So this is pretty known. But I think it's an important starting point for being fast and having velocity with teams. The problem comes from... There's one downside of that, obviously. If you have now, let's say, 20 or 100 of these teams, there's no specialization. Everyone is like expert for everything. Everyone does the same thing. You do the same problem solve again and again. So you're getting, basically, you don't get the power of a large organization. And I think the only way around that is communication, that you get these teams to talk to each other in an efficient way. And we put a lot of things in place to make this, facilitate this communication and help the teams to learn from each other, to align, to converge. So there are a lot of things. Internal tech talks, very simple, where someone says, I did this with React, it didn't work, now we try this or whatever, and then others don't do the same mistake. Tech radar, very simple way to visualize what are we all working on and what is our common shared belief. This one is the tool from Zalando, and you can very easily visualize what should we all as a team, basically wisdom of the crowd, adopt. I just read, you can't see it. We say AWS Lambda, Docker, Kubernetes, Terraform, S3, SNS, Elasticsearch, Postgres, Redis, JavaScript, Python, Scala, Swift. So these are the things that are in the core, what we were very sure that we all should use. And then it goes to trial, assess, and don't use Perl, Couchbase, JBoss, PHP Symfony. No, this is assess, sorry. I don't want to. All right. So this is our view, but it's more internally to align the teams so you have something to talk about. Another thing is what we call the principal engineering role. It's above the senior. He earns like a lead, and he's really the guy who I ask in his job description, you need to be a good contributor within, but also across the teams. You need to be an influencer and evangelizer. You need to be recognized, and you need to lead without being a manager. So to get this alignment between the teams, you need someone to lead that, and it can't be always the team leads. They have a lot to do. So we have these principals who their explicit role is not to manage, but to be the ones who create also glues between the teams while working on one topic. Other things are guilds, where people come together on a common topic like performance, security, or APIs, and also have the power to set up standards. We have internal consulting team for some functions, where people then go from team to team. They are not working on a topic, but they are the security gurus and then can help and consult the teams without taking ownership. We have make sure we have a common monitoring and benchmarking system so we can use the data and know who's good, who's bad, so you can have a discussion around it. We have standards. We use an RPC request, call for paper process on GitHub, where people then actually use GitHub pull request to agree on how we do things. That works quite well. We work quite a lot on making sure we have a common language on things and use the same tools. And a new thing we are starting now is an innovation week, where we just for a whole week get everyone mixed up and work on completely new topics to also make sure that people get to know each other across teams. So all this is, I think, is necessary to make sure the teams don't go in the silo mode and you don't have any, you're not more than just the parts. That's the team level. Now I would like to go one step up. Maybe how we now organize the teams. It's not enough that the team is fast and they align, but somehow we still have dependencies. If we currently probably have 60 teams or 80 teams, how do we structure that? And one really obvious thing is to structure those teams across the consumer journey. From growth, we call it a growth team. How does the customer arrive on our platform? To discovery, how does he find the product he loves? To cart and upselling, and then to order, and it goes on. Then it's post-order. If he has a problem, how's that solved? Does he know delivery status? And it seems simple, but I think it's important that we don't structure teams around how it is technically convenient. How obviously you could have an app team and a back-end team and a front-end. It's much easier, much cleaner, separated technically. But we structure, and Spotify does the same, obviously, around products, because the big advantage is then you can give the teams not product goals, and product goals are in the end customer-facing goals. So if you would be a back-end teams, it's hard to do that. But if you're a growth team, you can say, from the people we acquire, we want to get whatever, 50% to order and do whatever it takes. Or the discovery team, the people who find something, they should come back, because probably if you show them the wrong, they won't come back, and so on. On cart, they shouldn't drop out at that stage. On post-order, we should make sure if we get a rating from a customer that they had a really good support experience and all that. So you can align the business goals really nicely with the team goals, and that drives, I think, both purpose, alignment with the business, and a lot of good things. But we are not just the consumer journey. If you look at the whole picture, we actually do have 3 big customers. We are the consumers who eat, the restaurants who cook, and the drivers who drive forth and back all the time between them. And so what we did is basically structure our whole business around these, we call it verticals, and also structure the tech teams around it. And even went one step further. So we have consumer tech, restaurant tech, logistics tech, but also then ad tech, for example, the team that is really working for the marketing, performance marketing team to give them the tools they need. And we are planning to do fintechs because we have actually a lot around financial problems, billing, payment, BaFin regulations, payouts, and fraud, and all this is another vertical in its own. People tech we also have, it's just our people, the team that works on making our teams more productive. So I think that is a very nice way of structuring high-level your teams. And what we then do in these verticals, as we call it, we say they are almost running like a small company. They have their own product and tech leadership. They have their own infrastructure and operations, their own customer service. So for internal customers, they have their own business intelligence, data science, and they should sit really close to the customers. So if I'm a marketing tech team, this team sits next to the marketing, performance marketing team. And the advantage of that is that they really get experts. Yeah, they talk, go out for lunch, go to the same team events, and learn a lot about the tool chain, the problems, the whole language around marketing. It's a whole world on its own. And these guys became, even though they maybe started as normal developers, are now actual real ed tech guys. And that helps a lot to make sure there's this good communication between the business and the tech teams. So that is the next level, but it doesn't stop there. We have one more level, and that is the global level, which we have to figure out. Because as you remember, we have bought all these teams, and actually we have 12 different locations right now where coders are building code for us. And I use some pictures to show that. So on the left side, you see a selection of the apps we have, Talabat, Hunger Station, Carriage, Amexipity, all food delivery apps around the world, and then the teams for that. So the first one, it would be in Istanbul. The next one is here in Berlin, a team. Then we have a team in Korea, a team in Bogota. Below is a team in Kuwait City. And finally in Riyadh in Saudi Arabia. So, and this is not all. This is just to give you a taste of the whole team. I think this is quite unique to have such a distributed team. And I think the first reaction, I think I counted in total, we have up to 50 different apps with iOS and Android. And you would say, wow, this is inefficient. Yeah, this is crazy almost. Why would you do that? They all do more or less the same. So, yes, to a degree, but there's two things. First of all, as we saw before, smaller teams are more efficient. Smaller teams just work faster. So if we would now group all these 6 teams we see here in one and make them all build one app, they would be by definition slower at that and not as efficient. So, and as you know, our main goal is not efficiency. I think this is something more of what developers tend to do. It seems like a problem we can refactor. Yeah, why you shouldn't repeat yourself. I shouldn't have duplicated code. But from a business perspective, we need velocity. We need to be as fast as possible to compete. And with having these separate teams, we can really compete much faster. It has another big advantage, and that what I call is like parallel innovation. We have all these teams somehow competing against each other. They are our internal race cars. And by making the leaderboards very transparent, so everyone can see at any time what's my conversion rate across all the others, what's my, not just conversion rate, all the funnel micro conversions, how many problems do I have on delivery, how many payment issues do I have. And all these problems are transparent and measured by the same standards. And then if someone is better, of course, it's in our own all interest to say, talk to each other. And if you're alone and you think you're great because of, let's say, 25% conversion rate, maybe you're not great because we have others with 35 or even more conversion rate, so learn from them. And all the time these teams do A/B test and come up with new hypotheses, what could be fun for the user and make the experience better, and that once something is working and shows in the data, we apply it across the world. So I think that is super powerful. And the last one, not to be underestimated, is that we are inherently a very local business. So it's more or less the same, but this more or less is quite tricky. It starts with 150 different payment methods we have to integrate, because you have boletos in Brazil, and you have food vouchers in Istanbul, and you have Klarna in Sweden. But then we have all these integrations with the restaurants. We integrate with all these directly into the chains. We have languages, we have legal frameworks, and we have different address systems and so on. But we have also, what I really like are these cultural specifics, which maybe seem small, but locally they make a big difference. If there's a Ramadan, people all order at sunset, because that's when you're allowed to eat. And suddenly you have your system might be overloaded, or your restaurant or your drivers can't handle it. So you need to build features around that, so you can pre-order and so on. In Saudi Arabia, there are prayer times, so the whole country stops working. So you're not allowed to do delivery or take orders, so we need to shut down our system at those times, 5 times a day. In Kuwait, there are no such things as house numbers, so it's much harder to find your customer. In Thailand, we have monsoons. So we have a special monsoon feature where the cloud is above the city. When this really rains, you cannot drive there. It's just impossible. So we can turn out off regions based on the weather, and it goes on like that. In Germany, we have BaFin regulations. In Brazil, it's the hardest tax system in the world, and so on. So I think it gives us quite some power that we can localize really fast with these local teams. Obviously, if we would only do this, again, we would probably be not racing with the big guys or able, because then we would just be a collection of startups. So we do more. And what we do is basically we separate from our platforms, which you might have bought, over time, take key components out of them. Sometimes they are new, like the purple here, or they might be part of a platform that is very good. And then take that out and basically promote it to a global service. So other platforms can connect to it and can reuse that. I give you an example is our logistics, how we route drivers around the country is a very complex problem, very hard, and we solved it really good. We have the perfect algorithm, let's say. So why not every platform should develop this algorithm again, but we servicify it, make what we call delivery hero web service out of it, and provide it as an API to all the platforms. So the platforms over time have less responsibility. Their core is to make great customer experience, and all the things, let's say, below the water, this iceberg, ice mountain, where this is really where we build really great services, and then we can invest. We have a big team, for example, just working on recommendation, as I showed in the beginning, to really get smart around what customers want and how we can give individual recommendations on food. So it's not just a theory. We have a whole website, the API hub, where you can go in and on all these topics, restaurant, consumers, internal systems. You get ready components you can then plug together to build and scale. So in summary, I really like this system. I really think it's a good one because we call it the delivery hero model. We combine really these local strengths, really fast innovations locally with very strong global services, and that is our unique way of tackling the global scale. So we talked about organization from the team level to verticals, organizing across the value chain, the consumer journey, and then to the global organization. And I think all these steps are in the end done to allow us to move faster and innovate faster. But it wouldn't help to reduce all the dependency on the people side if they still exist on the technical side. So I think it has to go hand in hand with an architecture and operations. And I'll go into that, and I think I need a bit more than 5 minutes for that, but I speed up. So I think we need some common things, and let's start like that. I don't really care what happens inside the team, and we have, I do care, but what they choose as technology. We have Java and .NET and PHP and Python and Golang and Scala and more. We have Travis and Circus CI and Jenkins and more. And we have basically Scrum and other forms of Agile. As long as it's inside the team, I think the team should decide. They should be autonomous and pick the tools and the way to solve the problem that they think is the best, based with all the experience we have. But as long as we when we start talking about connections between the teams, externalities, then I really care a lot, and that's what we work on. So it starts with communication. Obviously, we need a common set of tools. All agree worldwide on Slack and apps and Jira and GitHub. That's how we communicate. It goes to naming. And it seems simple, but you read that also in Fowler with the domain-driven designs. Actually, names and domain modeling is harder than you think. And just to agree worldwide on how do we call things, where do we do the boundaries between the domains was a big work. And coming up with this global map of things, so we all talk about the same thing. Also with the business was important. It goes to APIs. Obviously, we have to set up good standards. How do you do security authentication and all these things around APIs, and ideally the same. So it's easy to integrate our things. But then also speed, scale, uptime are things we cannot be flexible about. Because if my system is not up, it's not only my problem, but all the users, other services using it. So we have a way to set up, to basically monitor budgets for each service. So a budget would be, you can be down for so many minutes. You can be so slow, so much percentile. You can, and you have to scale to that level. And then we have a system to monitor that. And actually a team, if the teams run out of budget, then an external team can get in and help them and get them back on track, basically. Security obviously is also an externality. It's not just the team's problem if they lose their data. So we have a central security team that does consulting, pen testing, and monitoring, and make sure teams are at a high security level. And infrastructure, I make sure that each vertical has their own infrastructure set up to make sure there are no dependencies on the infrastructure level. But we are happy users of Kubernetes. It's mainly to reduce cost, to get the most out of the servers we have. It's running really well for us. We have most of the companies now running on it, and it just allows to get a really good utilization of your infrastructure. I have a few more learnings, and I just go quickly through them. First, on the microservice part, they really make sure their services fit well to the business domains you have. Be clear about a single responsibility per service. The same pattern we have on code applies, of course, for services. What's the leading system for each type of data? And be really strict about no shared databases, caches, queues. That if you do that, you don't do microservices. But it's, of course, it is okay to replicate data. You often need to do that for performance and resilience. We only allow services to talk via REST APIs to each other, no other communication. We don't share libraries between teams. It's okay to copy a library, but not to share, to just not create this dependency. If you really want to share a library, you have to make it open source. And I also like the idea that every service has to have a clear job title and job description, like in an organization. If it's not clear what's your job, how that is named, something is not is probably need to be fixed. And the same is true for services. The other things I already mentioned. Maybe the last one is important. Critical services may not be down if a non-critical service is down. So you have to define critical is like if this service has to be up so the customer can order, and it has to fail gracefully if a non-critical service like recommendation is not available. I think very important, if you are in the process of splitting down a monolith, go in small steps, and don't do it for technical convenience. Don't do it, this piece is so old and our code is so ugly, I want to get rid of it. That is not a good reason to split something, but there should always be a business value that is in the end a customer value. After you're done with this new service, shiny new, something important should change for the customer, something. Otherwise, I wouldn't start. And you realize, because the business should also be excited about it. They should really ask, when can we have this new recommendation engine finally. And the last one is on operations of these services. We do all services, new things now on AWS or Google Cloud. We use managed services quite happily where possible and useful. We use Postgres as a transactional database typically. Everything is on GitHub. We make the infrastructure has to be in GitHub. So with Terraform or CloudFormation, that works well. Kubernetes to orchestrate all the containers. Serverless is working for us quite well with Lambda for really small services. And what we really strive for, and many teams are there, is that you merge to master, and then that's the only thing you need to do to get things live, on staging at least. So it runs the test and code style checks and performance tests and builds and the container and deploys it and informs everyone in Slack. And then if you have this completely automated, obviously you can do it all the time. So we really strive to do tens or even more releases per day. Infrastructure should be immutable. That means a Docker image you create, you don't touch anymore. You can only destroy, but you don't change it anymore once it's in live. And we have a common logging infrastructure, common monitoring with New Relic, and all teams are on call for their services. And maybe the last thing is I really make sure that these topics like security, quality, stability is not a team's topic. Yeah, there's no quality team or security. It's a security team, but it's not their responsibility. Every single developer should be responsible for those things. And I really like quality is not something you give to someone else to do. It's your own. You should produce quality as a developer. So these are some of the learnings we made at Delivery Hero to speed up and win the race against some big guys. And we are optimizing every day to get better at it. And we are growing. So if you want to join, send me a mail. Thank you very much. So we have some minutes for questions, 5 or so. Someone.
So first of all, thank you very much for a lot of interesting information. I guess it was very hard to say so much information in just 45 minutes in class. Anyways, it was very interesting to hear. And I understand you have a lot of applications, which is basically different UI for regional customers.
Correct.
But then after the order is confirmed, you probably have a lot of same payment operations like invoicing, refunding, cancellation, sending reports to accounting. Is it implemented in the same, is it implemented separately on every separate app, or is it shared somehow, or as you said, service it? It's very interesting because it's pretty complicated problem itself. You have to do a lot there, and it's very interesting how you solve it, if you can reveal, of course.
Absolutely. That's exactly how we do it. The consumer-facing thing is replicated, but then what happens behind the scene should be ideally just one. For some areas, like logistics, it's exactly one. For another area, like all the communication with the restaurant and the tablets they have, it's one, but there are some variants. Not everyone is on it, but we are rolling it out country by country. For billing, for example, as you mentioned, we are currently building this global billing service, super complex project, but we think it's worth it because it's also no one really likes doing that right. Everyone, also the local teams, they are excited about the consumers, but some teams still do, some work with Excel there, and they're really happy if we build a solid service for them. Discovery, so the whole idea of using data to show individual recommendations, and every list page should be individualized. That is something which we solve one time, and then we are API provide to the front ends. So yeah, we do just that, but different services are at different maturities or at different levels of rollout across the group.
I wanted to thank you a lot for the talk. I thought it was very interesting. And you had one point, I actually had two questions. I'll start with the first one. We were talking about identifying sort of like core components that you see in multiple local teams and then creating a shared service for that. And I was wondering, how does that, once it becomes a shared service, what kind of team do you form around it, or how is that formed? Because do you still have an end-to-end team, or does it become like a tech team, and what do their OKRs look like in that case?
So the local platforms are run by the local, also in the end report to the local CEO. So there's a CEO for Middle East, and he has his Middle Eastern platform. But once they build a service that is global, it reports into the global tech organization. So basically my team then is responsible for it. We have a global product and global tech leadership for that. And the actual service doesn't have to be built here centrally in Berlin. We have some service, for example, in Turkey that is used globally. Another one we built in Montevideo right now. So this is also a great way to convert those organizations which were initially basically a brand that we maybe acquired to become step by step become tech centers of a global organization and become experts in one area. For example, advertising, which is a part of our revenue stream. And how we manage them, we set global OKRs. So our CPO, Chief Product Officer, is basically setting the goals for those teams because obviously they can't be driven by their local CEO. They have to be running on a low. We need to globally decide what are their priorities.
Cool, thanks. And then the second question I had, in the last bit, you were talking about standards across teams. And I was just wondering on what level does that sit? So your ideal team was eight people. But then when you were talking about the standards across teams, for instance, when not sharing a library, do you also mean across these 8 people teams, or do you mean more across the local teams? To have those standards?
No, across services is that. So between one microservice shouldn't share a library with another, but the standards are defined globally. So what we do actually, we meet with all CTOs once a week on that. And we go one topic at a time, and someone makes a draft standard, and we discuss it and comment on it and come back till it's really refined to a level that everyone agrees. This is the way, for example, we operate a global service. These are the SLAs around it. And I think that is a very important process. So it's not me setting a standard for the group, but we all agree on that. Because the local CTOs use those services and they need to somehow trust them. And so if they were involved in the standards, then that helps. Yeah.
Hi, thanks for the talk. You talked about a lot microservices, which means encapsulation and delegation to individual team, a lot of autonomy. But what about data? When you talk about recommendation, this is very much about bringing sources of data together all over the place.
Yeah.
And then starting steering processes, meaning influence the behavior of individual microservices. So, which goes kind of like in a direction of a data monolith somehow. So how do you deal with this, this spectrum?
The right way to do it is that you copy data, but you still, let's say, we have an order process or order engine. It is owner of the order data, of the order table. So it's the authoritative source of truth for an order and its state. A lot of other systems need to know this information. The customer service system, but also the recommendation system, because it's of course very important what I ordered in the past to give me recommendations for the future. So we publish this information on queues. So the system would say there's a new order, and then we pull the interesting system pull the data via APIs. So we don't send the whole order, but we just send a status notification, new order, that makes the actually message very thin, and we don't run into difficult problems with schema changes, but then there's a normal REST API to get the data. And then the recommendation system would then pull this data and store it in the efficient way, in our case, an Elasticsearch, to serve the front ends. So then again, the front ends use a recommendation API to get this. But the recommendation system needs, of course, a lot of data sources. That's somehow the spider, which the more it knows, the better the recommendations get, including where does the user click, if it's in which, not just if I select a restaurant, how long do I scroll? If I have to scroll a lot, probably the recommendation was not so good. If I take one of the top things, then I found something that fits. How long did I take? How often did I go forward and back? And all that needs to be known to the system to be able to be really efficient. So that it's an interesting problem to solve. Mm-hmm. Yes?
You're now working on economies of scale in the market.
Yeah.
I'll start again. You're now working on economies of scale in the food market. Do you also think about economies of scope, going to some other products similar?
We really like food, as you see on this picture, and I think that is also our strength. If you take Amazon, they do just about everything, so from diapers to food to clothes and so on. If you take Uber, yeah, they do food, but they're still a taxi company at its core. We have a food company at the core, so that's what we will always do. But we might innovate along the value chain of food delivery, so that there's obviously room to do things. Yeah. Any more questions? No? Ah, there's one too.
You talked about how different teams could compare by looking at the conversion rate.
Yeah.
But if you have different countries, it might be that the conversion rate is country dependent. How do you deal with that difference?
Yes, conversion rate is dependent on a lot of things, mostly on marketing. If you do a lot of push, then you get the wrong customer and they don't convert. But if best is to look at only returning user conversion rate, that takes out that part. And then we think, and it also is, of course, what kind of products you offer. If you don't have great restaurants, why should people convert? But especially when you go through the different steps, how many convert from location to restaurant list, from restaurant list to order, and so on, or what you call micro conversion. It's not really, there shouldn't be a reason why a user in Turkey, 30% of them make that step, but in Greece they don't also. And it's quite big differences within the group. It's not that we are all the same level, and I think it's a lot about A/B testing and refining the user interface and finding all the little things that turn people off or confuse them. So I think a lot of things are comparable. Maybe not to the percentage level, but if someone is 10% better, there is something to learn from it, for sure. Mm-hmm. Yes?
When you give the team the responsibility for the quality assurance as for the whole product, from my experience, people with doing quality assurance have different personality, different mindset than creative developers. Mm-hmm. Do you have specialists in the teams or not?
Yes, I think clearly the actual manual testing would be a bit of a waste to have a very expensive senior developer doing manual testing all the time. So that can be done by so often there is one specific QA person inside the team, but I learned that the actual test automation is not so easy to outsource to someone. I think you get much better results if you have the team be responsible for that. Not just unit test, but also the functional test, the click test. Because otherwise, if it's basically more junior people doing that, it becomes very brittle. If you change the product, those tests constantly break and don't add so much value. But at our scale, a functional test on the app, for example, to do auto click tests, if everything is working before a release, are quite important, so we can release often. So that is responsible of the developers. And I think it's also just a bit of a mindset that you say you don't hand this over like in these Kanban boards. Now it's QA and I'm done. You solve the problems are not mine anymore. So I tell the developers typically, if you take a ticket, you bring it to develop to life. That it's your baby. You don't drop it until it's really done, and you care about it. And why not test it yourself? If it's you know what you did, you can test it differently. But I think QA is more a level of sanity check that we don't overlook something. Also, I saw a really nice process what we do in some teams. What I can recommend is to make the whole team responsible. The QA wrote all the test cases on paper, on cards, and then every time we release an app, the team gets in a room, and you pick any card, and you eat while you do it, and you order food. And then everyone, does. You have 200 test cases or so, and everyone does 10 of them, and then or 20, then you're quite fast done, and you make it a team responsibility, and the whole team then stands behind this app. And I really like that as a process, I must say. Mm-hmm. Yes?
Also, you mentioned that in your teams, you want to see that people know everything. And this, in the couple of years recent, there were so many new technologies. Like 5 years ago, you could physically be full stack developer, do front and back end. Yeah. It was possible. Right now, the scale is unbelievable, and it's very hard to ask front end developer to set up Kubernetes or something like that. Or
actually,
you can make a lot of analogies, and then you can get a problem of jack of all trades, master of none. Do you still want to see front end developers setting up Docker stuff, or you have some specializations? It will be interesting to hear how you consider it. Thank you.
I actually have a few front-end developers, React developers that are good at Kubernetes, which is possible, it seems. I think front-end also gets much, much harder. In the past, front-end was more low end. Now I see front-end developers sometimes are more expensive than the senior back-end developers because it's getting so hard. So I think from the capacity, they can of course do it intellectually. But then it's a bit about interest. And I don't say in a team everyone needs to do everything. I think there should be specialization. Someone who's really good at database, query optimization, performance, someone who's really good at CSS. It's more that you're not, this might be then 75% of your time, but you're not just that. And if you get a feature and I need to do a bit of CSS for it, it's a bit like when I do my private project. I have to do it all. I have to do product manager from CSS. I have to set up the infrastructure. So, and it's fun. I think it's not too much asked, but of course I want specialization within the team. All right. Thank you very much. It was a pleasure.